Okay, blockchain. It's a word you hear everywhere, right? But what is it? Really? Let's forget all the hype for just a minute. Because at its heart, blockchain isn't really about money, it's about trust. Today, we're going to pull back the curtain and demystify how this technology solves a problem that's basically as old as people. So, picture this. You've got to make a huge decision with a group of people. There's just one problem. You have no idea who's on your side and who might be a traitor, actively trying to sabotage the whole thing. How do you possibly agree on what to do when you literally can't trust anyone in the room? Now, this isn't just some random thought experiment. It's actually a famous puzzle in computer science, but it's framed as this epic, ancient military dilemma. It's called the Byzantine general's problem. And it perfectly captures the challenge of getting a group to agree on something when there's no central leader and, you guessed it, zero trust. Okay, so here are the rules of the game. You've got these generals surrounding a city. They all have to agree on one plan, either attack or retreat. A split decision, that means certain defeat. The catch is, they can only talk using messengers, and some of those generals might be traitors, sending out fake messages to cause total chaos. So the big question is, how do all the loyal generals get on the same page? You see, this ancient problem of trust, it's the exact same problem that modern digital systems have been wrestling with for decades. And the solution? Well, it takes us from an ancient battlefield right into the digital world of cryptography. Decades before Bitcoin was even a twinkle in anyone's eye, a cryptographer named David Chaum just nailed the challenge. He imagined systems that could be trusted even when the people using them were totally suspicious of each other. And that idea is the bedrock that blockchain was built on. Which, of course, brings us to the solution, blockchain. For a second, don't think of it as a technology. Think of it as a brilliant new rulebook. It's a system designed from the ground up to let a group of total strangers, just like our generals, cooperate and agree on a single version of the truth without needing a king or a bank or any central commander telling them what to do. So, how in the world does this magic rulebook actually work? Well, it all comes down to three key pillars that, when you put them together, create this amazing new way to agree on things without trust. Pillar number one is cryptography, basically the science of secret codes. In our general story, this is what makes sure the messages are sealed tight, so a traitor can't just forge an order to attack when the real message was retreat. It's the lock and key for the entire digital world. And this analogy just explains it perfectly. Imagine your digital wallet is like a little shop with two doors. The front door, that's your public key. It's open for business, anyone can come by and drop something off for you. But the back door, that's locked, and only you have the private key to open it and get what's inside. That's how anyone can send you something securely, without you ever having to share your secret key. Okay, pillar number two is the structure itself. Now, this diagram might look a little complicated, but the idea behind it is actually super simple. The basic unit of a blockchain is called a block. The best way to think of it is as a single page in a big shared digital record book. And this page records a bunch of transactions, or in our story, all the messages and decisions from the generals. And every single one of these blocks or pages gets a timestamp. Now, this is absolutely crucial. It proves the exact moment the block was created, locking all those transactions into a specific point in time, and more importantly, in the right order. This means nobody can go back later and try to secretly change the history of what happened. Now, this is where things get really, really clever. To add a new page to this digital book, people called miners have to solve a super hard math puzzle. They do it by guessing a random number called a nonce, and finding this number takes a ton of computer power. This whole process is called proof of work, and it's what makes the network so secure. It makes it incredibly expensive and difficult to cheat, and it's how a new block gets validated and added to the chain. And here's how it all comes together. Each new block contains a cryptographic fingerprint of the one before it, forming this long, unbreakable chain. So if you wanted to change something in an old block, you'd have to re-solve the puzzle for that block, and for every single block that came after it. It's a nearly impossible task, and the result is a permanent, transparent, unchangeable record of everything. And that brings us to the third and final pillar, the consensus mechanism. This is the secret sauce. It's the set of rules that truly solves the Byzantine general's problem. It's how the whole network, all the computers, all the participants agree on which new blocks are legit and which ones aren't. It guarantees that all the loyal generals will eventually agree on the exact same version of history. So we've got this incredible theoretical solution. But how did it actually jump from an idea on paper to a technology that's changing the world? Well, the first big real-world test was, of course, Bitcoin. But believe me, the story was just getting started.
This slide just lays out the journey perfectly. It all started with blockchain 1.0, Bitcoin. Back in 2009, it proved this whole crazy idea could actually work for digital cash. Then came blockchain 2.0, led by Ethereum. This introduced smart contracts, which are basically agreements written directly into code. This was a huge leap. It turned the blockchain from a simple ledger into a kind of global, decentralized computer. And now, we're in the era of blockchain 3.0, which is the engine behind Web3 and all these decentralized apps, or DApps.
And because of that incredible evolution, the uses for this stuff are just exploding, way beyond digital money. We're talking about creating totally transparent supply chains, securing our private medical records, building fraud-proof voting systems, and even giving us as individuals true control and ownership over our digital identities. The potential is just massive. But what happens when the rules of the blockchain itself need an update? That's done through something called a fork. Think of a soft fork like a software update on your phone. It adds new features, but it's still compatible with the old version. A hard fork, on the other hand, is a fundamental change to the rules. It is not backward compatible, and it can create a permanent split if the community can't agree on the new direction. And this visual just shows the difference perfectly. With a soft fork, it's like adding a new lane to a highway. Traffic still flows on one continuous road. But with a hard fork, the chain literally splits in two. The old path follows the old rules, and a brand new path is created with the new rules. You end up with two separate blockchains, and a lot of the time, two separate currencies. So after this whole journey, from an ancient military puzzle to a globe-spanning digital network, we kind of have to ask ourselves, where does this all leave us? What does the future of trust even look like in a decentralized world? All right, so what are the big things to take away from all this? First, blockchain is a solution to that ancient problem of getting people to coordinate without a boss. Second, it's built on those three pillars: super secure cryptography, a permanent chain of blocks, and a consensus protocol. Third, it started with Bitcoin, but now it's about so much more than just money. And finally, it gives us something we've never had before: a new foundation for digital trust. And that really brings us to one last powerful idea. See, for pretty much all of human history, trust has been a social thing. It's built on reputation, on laws, on shared values. But now, trust can also be a technological guarantee. And that leaves us with one final, absolutely massive question. We've just seen how a brilliant combination of math and computer science can solve for trust. So if we can now build systems that let total strangers cooperate and agree on a global scale, what other impossible problems can we solve next?